Today we're going to start chapter 3, which is all about modeling relationships with functions. We're going to focus mainly on linear and quadratic functions in this particular unit. So first we need to kind of just do a review of all of the different types of parent functions that we might encounter this school year. The first one is called a constant function. So when we are looking at a constant, it means it's just a number, like y equals 7, y equals negative 14. So when we write our general equation here, we get y equals some constant. And so a sketch of what these constant functions might look like, so there's my xy axis. A constant function is just a horizontal line at whatever that c value was. A linear function is one where we see y equals x or mx plus b or some form of a straight line. And so a general sketch of a linear function, we get one of those types of lines. A quadratic function is anything that you're going to see with a second degree. So y equals x squared. And the picture of that particular function is going to be a parabola. A cubic is any function that is x to the third. And so the general shape of a cubic is kind of a snake-like pattern. And then a square root function, y equals the square root of x, is going to look more like that. Notice that square root can't be negative because we can't take the square root of negative numbers. The last four up here are ones that you were introduced to in Algebra 2. So an absolute value function, y equals the absolute value of x. When we sketch the graph of this type of a function, it behaves like negative x on the left, and then it behaves like positive x on the right. So it looks like a V. When we talk about rational or reciprocal functions, we're talking about the functions that look like 1 over x. And what we recognize is that x can never be 0. And so what we talked about in Algebra 2 was that gives us asymptotes. And so this particular function would have a vertical asymptote at 0. And this one actually has a horizontal asymptote at 0 as well. And so this rational function or reciprocal function looks like this. We've got a branch over here, and we've got a branch over here. For our exponential functions, we've got two different types, growth and decay. So we've got a to the x, where a is bigger than 1. That's going to be growth. And we've got y equals a to the x when a is between 0 and 1. So we have a fraction. And so that's going to give us decay. So our exponential growth starts small and gets big fast. And then exponential decay starts big and gets small fast. And then our logarithmic function, we talked about two different types of logs. We have log of x or natural log of x. The general shape of both of those is exactly the same. Logarithms are the inverses of exponential. So since this one had a horizontal asymptote, it means this one will have a vertical asymptote. And it looks a little bit like that. So in section 3.1, we're going to focus on those linear functions. You're going to want to keep that function family document handy throughout the rest of the school year because those are the general shapes of all of the graphs we're going to be talking about. So in section 3.1, we're going to start all the way back to kind of an algebra 1 skill, which was talking about the slope of a line. In IB, instead of using the word slope, they'll use the word gradient or the grade of that function. So there's a constant rate of change between any 2 points on the graph of a line. This constant rate of change is called the gradient or the slope. So just as some review, when they ask us to find the gradient or the slope of a function, especially when it's on a graph, we can pick 2 nice points. I'm going to pick these 2, and then we can just do rise over run. And so here I went up 1, 2, 3, and we went over 2. So this one would have a gradient of 3 over 2. On this graph, I can see a nice point here, and I see a nice point here. And so my rise over run, I went down 4 and over 1. So my slope would be -4 over 1. When we have 2 ordered pairs, just a reminder for slope, we're doing the change in y over the change in x. Yes, that formula is even in your formula booklets. You don't even have to memorize that one. So for this particular problem, y2 minus y1 over x2 minus x1 gets us 3 over 2. And on the second one, y2 minus y1 over x2 minus x1, we get -4 over 1. So the real world application here, when we are talking about slopes and gradients, we're talking about these rates of change. And so this one says, on a certain day in 2017, 4 people exchanged US dollars to Canadian dollars. The amounts they exchanged and received are shown in the table and the graph below. This data is linear. Find the gradient of the line joining these points and explain what the gradient of this line tells you. So you can pick 2 ordered pairs. It doesn't matter which 2 you pick. I'm personally going to just pick these first 2. And so I'm going to do y2 minus y1. So 1250 minus 625 over 10 minus 5. And so if I put that into my calculator, I get 1.25. So the meaning of this one, if you want to write this in, the meaning is that that's the average rate of change in the exchange rate from US dollars to Canadian dollars. So $1.25 Canadian would equal $1 US. So this is the average rate of change where $1.25 Canadian would represent $1 US. So some vocab review in this first section. When 2 lines are parallel, what do we know about the slopes of those lines? Well, what we should remember is that parallel lines never touch. And so looking at these 2 lines, it means they have the same slope. And when I'm looking at perpendicular lines, that means they form a 90-degree angle. What we know about the slopes of those lines is that they are opposite reciprocals. You might also recall When you multiply the slopes together, you get -1. So if you can multiply those two slopes and get an answer of -1, it means they are perpendicular. So here it says find the gradient of all these lines given through these points and then identify them as parallel or perpendicular and justify algebraically. So we need to find the slope of all 4 lines. So go ahead and do that a minute. So I've got all of my slopes written here. I'm looking for parallel lines would have identical slopes. The only two that I see that are identical are line 2 is parallel to line 3. Those two had the same slope. For perpendicular, I'm looking for a pair of lines that have opposite reciprocal slopes. I see one opposite, meaning they have opposite signs. So one is positive, one is negative, and they are reciprocals. You have to flip them. So I can see that that happens with line 1 being perpendicular to line 4. Opposite reciprocal slopes. And then just to prove what I had said earlier, 2/3 times -3/2. When I multiply these, I get -6 over +6, which is -1. So that's just another way to prove that those two lines are perpendicular.